on to section 5.2. We are still solving inequalities. Yesterday we used addition and subtraction to solve our inequalities. Today we will use multiplication and division. I want to start with some more of these verbal sentences like we started with yesterday. The first one says 4 times a number is no more than 108. 4 times a number, we know what that expression looks like. 4x or 4n, whatever variable we're wanting to use, is no more than, what does that mean? I wrote it down yesterday.
Is it less?
Than or equal to. It should be under that column, is it? You look at your notes from yesterday. We wrote down, didn't we write no more than? Or maybe we wrote no less than. I can't remember which one we wrote down.
Yeah, no less than.
Okay, so no more than, okay, think of it this way. No more than is not more than, so it would have to be less than. It could also be equal to 108. Yesterday we talked about defining our variables. What variable did we use in this inequality? What did we use? X. So to define our variable, we need to let them know what x is. X is the number that we're using. We're not going to solve for the time being, but you will be able to solve these here in a little bit. Number 2 says 3 times a number is at least 12. Well, 3 times a number, that's like 3x. At least is what symbol?
Greater than or equal to.
Correct. Greater than or equal to 12. And once again, we use the variable x, so let's define our variable. X in our situation, in this word problem, is talking about a number. Or the number, however you want to say it. Number 3, 5 times a number is at most 100. 5 times a number is at most 100. 5 times a number is 5. We'll use a this time. At most is less than or equal to 100. And we use the variable a, so a in our case is representing the number. So let's go ahead and practice solving some of these inequalities. If you would please copy down example A into your notes. We'll start there. P divided by 2 is less than negative 1. P divided by 2 is less than negative 1. We're solving for P. Think about your equations that you know how to solve. If you're dividing by a number, what undoes that division? Multiplication. Let's start by multiplying both sides of our equation by 2. When we multiply by 2, we're left with P is less than negative 2. I would like for you to go ahead and graph. Will we use an open or a closed circle at negative 2? Open. And we know it's open because the inequality symbol is less than. It is not equal to. What direction will our graph go to show or represent numbers less than negative 2? To the left. Example B. Copy that down in your notes, please. 2.5y is greater than 3. 2.5y is greater than 3. We're solving for y. What would you do? to 5. We're going to divide both sides by 2.5. So we have y is greater than 1.2. So let's graph this. There's a number of different ways that you could graph 1.2 on your number line. This is just one way. I'm using 1, 1.1, 1.2, 1.3, 1.4. You could have used 1 and 2 and put marks between the numbers 1 and 2 to represent 2/10. At 1.2, will you use an open or a closed circle? Open. And again, I know it's open because my inequality symbol here is not equal to. What direction will my graph go to show all numbers greater than 1.2?
Right.
To the right. I would like you to try examples C and D, please, on your own, and work these problems. On example C, what did you do to solve?
Multiply by 3.
Multiply by 3. By multiplying by 3, we're left with A is less than or equal to 36. Did you use an open or closed circle at 36? Closed. In what direction will our graph go? To the left. On example D, what did you do to solve? So n is greater than 1.5. Like I said previously, there's lots of different ways that you could graph these decimal answers. Oh, it would be 0. Did you use an open or a closed circle at 1.5? Open. And what direction is our graph going to show numbers greater than 1.5? To the right. Alright, let's move on. There are some other examples that we need to make sure that we're okay with. Example A, we have 1/4 x is less than 8. 1/4 x is less than 8. This is a situation where normally we would divide. If we're multiplying by a variable, we divide, but not if there's a fraction there. What did we learn when we solved the equation that is a better way to solve rather than dividing by 1/4? Thank you, Colin. And we can multiply by its reciprocal. And what is the reciprocal of 1/4? 4 over 1. So let's multiply both sides of our equation by 4 over 1, or 4. 4 times 1/4 is 4 over 4, or 1. So we have 1x, or just x, is less than 32. At 32, are we going to use an open or a closed circle? An open, and I know it's open because it's not equal to. What direction will my graph go to show numbers less than? To the left. Example B, we have 3/4 x is less than or equal to 15. This is another example where we're multiplying by a fraction. Instead of dividing by 3/4, what's a better option for solving? Multiply by its reciprocal. I'm going to multiply both sides by 4 over 3. 4/3 times 3/4 is 12/12 or 1. So we have 1x or x is less than or equal to. On the right side, I'll multiply the numerators and multiply the denominators. 15 times 4 is 60, and 1 times 3 is 3. Go ahead and simplify. What is 60 divided by 3? 20. So we have x is less than or equal to 20. Let's graph this inequality. Will we use an open or a closed circle at 20? A closed circle. And what directions are our graph going to go to represent numbers less than or equal to 20? To the left. Just a reminder, we know this graph is going to be a closed circle because our inequality here is less than or equal to. Example C on this slide says 1 is greater than 2/3 x. 1 is greater than 2/3 x. What are we going to do to get rid of the 2/3? Multiply by 3/2. So 1 times 3/2 is 3/2. 2/3 times 3/2 is 6/6, which is really 1. So we have 1x or x. Don't leave it like this. Don't leave it as 3/2 is greater than x. Let's flip it around. X is less than 3/2. Make sure if you flip sides like that, that your inequality symbol also switches. Will we use an open or a closed circle at 3/2? An open. And what direction will we draw the graph to represent all the numbers that are less than 3/2? To the left. Okay, I have one more problem. This is going to be set up as a word problem. Mark walks at a rate of 3/4 of a mile per hour. He knows that it is at least 9 miles to Ox Lake. How long will it take Mark to get there? Write and solve an inequality to find the time. So Mark's taking a walk. He's going to walk at a rate of 3/4 of a mile per hour. And it's going to take him at least 9 miles to get to this lake. 3/4 of a mile per hour. That's kind of the key there. 3/4 per. What does per mean? In algebra, per means multiplication times the number of hours. Do we know how many hours it's going to take him? We don't. 3/4 times the number of hours. It's at least 9 miles. What symbol can I put there to represent at least? Greater than or equal to. This is one part they asked us to do, and that's set up an inequality. We need to define a variable. In our situation, what is H standing for? Number of hours. H is standing for the number of hours. Let's go ahead and solve this so we can figure out how long it's going to take Mark to get to this lake. To solve this equation, I think I would multiply by this reciprocal. Multiply by 4/3. So H is greater than or equal to. On the right side, 9 times 4 is 36. 1 times 3 is 3. And 36 divided by 3 is 12. 12 what?
Hours.
Hours. H is standing for the number of hours. So to answer the question. How long will it take Mark to get there? It will take Mark 12 hours to get there. Mark should probably find another mode of transportation. Borrow a bike, call a friend. It'll take him half a day to get this lake. So if you're asked to write an inequality of any sorts, I do want you to define a variable. Tell me what H is standing for. Sometimes it may just be the number. Sometimes, like in this case, it's the number of hours. It's something more specific. So please do define those variables. Okay, so today we just practiced solving our inequalities using multiplication and sometimes division. I do have some problems for you to practice. They're on a worksheet. You may or may not want to write some of your work on another sheet of paper. I'll kind of leave it up to you. Whited out some of the problems on this assignment. We're not ready to do all of them just yet. As soon as everyone has a paper, we'll talk about the assignment. I'm looking at this side that has page 14. On the top it says 5-2 practice. Now, number 2 up there, numbers 2 through 5, that's a matching section. Number 2, I believe that says 4/5. It's I kind of whited out the top of that fraction. On number 2, that says 4/5 right there, where it's kind of whited out. On the middle section, 9 through 22, the directions tell you to solve each inequality, check your solution. It doesn't say anything about graphing. I will not make you graph for these. You guys should be able to graph on number line anyway. So 9 through 22, we are just solving. You do not need to graph. Okay, the bottom 2 problems are word problems. I want you to define a variable, write an inequality, and solve for each of those. Go ahead and get started. If you guys want to group up and work, you may.
Wait, do we do the back too?
No, we're not doing the back yet. We will get there.
Back's in 30.